Hello everyone and welcome. This is the CyberSecStudy CISSP Video Bootcamp series. You're watching the free version of this domain. For access to the full version, go to the website at www.cybersecstudy.com. So hello everyone again, my name is Donald Parker. The reason you're watching this video is because you're interested in obtaining the CISSP certification, and in some cases you need it, right, for your job. The reason I'm here is because I developed a training program that can help you get past this doggone exam. So the program consists of a book of the course material, audio recordings of all of that content in the book. We have the video recordings now of all of the content of all 8 domains. I developed a Jeopardy style game that has questions that are based from the course material, and then a Kahoot competition style game where folks can compete and test their knowledge of the information in the course material. So this is a copy of the book. It's a little thicker than I really wanted it to be. But this is a hard copy version of the course material. If you purchase the audio or the video, then I'll also give you a soft copy of this course material. So for the book, it took me several years to write this book. I used several sources. The common body of knowledge, of course, the CBK is the most authoritative source. I also used the late great Sean Harris's all-in-one study guide. It's a phenomenal book. I used several practice question exam books that had explanations, very good explanations of key terms and concepts, and then the internet, of course. So I went through all these sources. I tried to group together the smallest grouping of terms that I thought would help you pass the exam. So I tried to, I categorized all these terms into either just terms, informational notes, concepts, and something I call muscle memory, which is all those algorithms and the OSI model and the ports and protocols and all that stuff that's just muscle memory that we have to memorize. I broke that out separately so that you could print out those muscle memory charts and focus on the muscle memory separate from understanding the terms and the concepts that I want you to know. So the focus of my book, of this course material, is to identify key terms and to expose you to those key terms in many different ways. I went through a couple of boot camps myself. I've taught boot camps with other people's course material, and what I've felt from those classes is that they were just throwing a bunch of information at you, just a ton of information. There's no way any of that stuff was sticking. So the intent of my program is to identify key terms so that when you're taking that exam and you're reading a test question, you see 3 or 4 key words, and those will point you to the correct answer. So we go through, as you go through this video series, you'll see these and hear these key terms. When we play rounds of Jeopardy, they're focused on these key terms. And when you test your knowledge with Kahoot, you're going to see these key terms again. So multiple times you're seeing these key terms and they're just embedded in your brain. So you could purchase the book, read the book. You could listen to the audio, which is just a verbatim, word for word illustration of the book. You can read or listen to the audio and follow along in the book at the same time. You could purchase the video series that you're looking at now, the full version of the video series for all 8 domains, which is the video recordings are a recording of a boot camp we just finished a couple of weeks ago. It turned out a lot better than I expected, and I think it can be really helpful. You could also watch or compete in rounds of Jeopardy, which, after you've gone through all the material and you're ready to see where you're at and test your knowledge, there are 15 rounds of Jeopardy to get through all 8 domains. But then Kahoot. Kahoot is something that we do on a weekly basis in the evenings. You could, if you go to the website and purchase the ability to compete in one of these competitions, there's one for each domain. The number of questions varies, but after you compete in this competition against other people who are preparing for the exam, it gives me a spreadsheet of every question and every answer, whether you answered wrong or right, so that I can sit down with you and know where you're weak and where you're strong. The people who compete well at Kahoot pass the exam the first time, every time. So the question that I often get, I think I get more often than any other question is, what's my success rate? How many of my students actually pass the exam? So I've been teaching CISSP boot camps with my own material for about 5 or 6 years. I've been teaching the boot camp for over 10 years, but all of my students pass the exam. If you go through my entire boot camp, I can tell you with the Kahoot rounds and the printout, the spreadsheet that comes out of that, I can tell you whether I think you're ready or not. If you're ready, you take the exam, those people pass every time. If you're not ready, I'll tell you, and I'll tell you what I think you need to work on. Now, I've had some folks who took the exam anyway, even after I told them that I think we need more time. They didn't pass the first time. I worked with them some more afterwards, and they passed the second time. So really, it's up to you. If you can get through all of this content, it's a marathon of material to get through. If you really want it, if you really need it, then if you can get through all of this content, I am very confident that you can get through the first time. But I would need to see you compete on Kahoot rounds in order to know for sure whether I think you're ready. All right, guys, that's it. Welcome to the program. Welcome to this journey to cybersecurity. It is the fastest growing industry in the world. It's the most exciting, in my opinion. I love what I do. I love working with this stuff. I love talking about it. I love sharing information. So again, if you're interested in the full version, go to www.cybersecstudy.com and take care. All right, guys. I think I mentioned this on Tuesday night, but I've just reinitiated my meetup group on meetup.com. So you can go to that website and search for CyberSecStudy meetup in the DC area. And we're going to start doing Kahoot rounds on Friday nights at 9 p.m. Eastern Standard Time. So I've got about 10 folks RSVP for that. So it'd be a good way for you guys to get more practice and compete against some other folks out there in the wild who should not be doing as well as we're doing. Right? So I'd love to have someone join just to have you measure up against some newbies. All right. Let's get started on domain number 3. This is a huge one, so hopefully we can tackle as much of it as we can. It's not that difficult a domain. I think we do kind of finish up with crypto. Again, that's my favorite. So term number 130, yet another word that we see, and in our mind, it's something that's a word we see all the time. We're familiar with what it means to us, but you get a group of folks together and use that word, and I guarantee everyone will have a slightly different interpretation. So a system is a set of interacting or independent components forming an integrated whole. System is a word that, again, I think we need to peel back or peel open just a bit and ensure that there's no ambiguity. So a system is comprised of parts, which I call components, that work together to achieve a goal or perform a function. So our refrigerator is a system. right? The components of the refrigerator system include the door handle, the door itself, the hinges, the drawers, the temperature dial that you can adjust, and then of course the motor and the cooling unit. You can have some of those components be configurable and some be non-configurable. A non-configurable component like the door handle on a refrigerator, if that breaks, you just take it off and replace it. But the temperature dial is a configurable system component. When that breaks, you take it out, you replace it, but then you have to configure it back to how it was originally set. We have a water system here that consists of pipes and then the different faucets and methods of turning it on and off. A computer system, an individual system, or you can have a system of systems. You know, when you use that word system, are you talking about one computer, or are you talking about multiple computers? Are you talking about telecommunications equipment and servers, telecommunications equipment, servers, workstations, and applications and databases? What exactly are we talking about when we say that word system? Make sure that there's no ambiguity. So system components are the hardware, firmware, and or software used to operate a system. And again, some can be configurable or non-configurable. Some non-configurable components of a computer system would be the RAM. You know, if that goes bad, you simply take it out, replace it, reboot the system, and keep going. If the operating system crashes, you get that frown, the Microsoft blue screen of death, and you need to reinstall the operating system and then reconfigure it. Non-configurable system components can be replaced and don't require any adjustment, blah, blah, blah. That's an informational note. We're going to skip through, try to get through this stuff as quickly as possible. An open system is simply one that interacts and continuously interacts with other systems. So if it's connected to a network, then it's an open system. If it's a standalone system, air-gapped all by itself and not connected to anything, then it's a closed system. And then computing devices, PDAs, smartphones, laptops, desktops, emanations, anytime a machine is used to process information electronically, the various switches, the contacts, relays, and other components in that machine may emit radio frequency or acoustic energy. And these emissions, like tiny radio broadcasts from the source, from that usually a copper wire, may radiate through free space, not very far, you know, maybe a couple of inches from the source of the copper wire cable, for example. Computer state is a word that we're going to hear a lot about throughout this program. According to Wikipedia, the state of a computer program is a technical term for all of the stored information at any given instant in time to which the program has access. So all the information on the system, if you go in and change a file, modify a file, you've changed the state of the computer. If you uninstall an application, you've changed the state of a computer. If you install a new application, you've changed the state. A state attack is also known as a race condition, which attempts to take advantage of how a system handles multiple requests. So a race condition or a state attack is the behavior of a software program where the output is dependent on the sequence or timing of other uncontrollable events. And it becomes an issue when events do not happen in the order the programmer intended. So a software developer writing a program and you know, a program to take input in a certain sequence, a hacker is going to try and break up that sequence or take advantage of a software developer not accounting for a situation where that sequence gets broken. Time of check, time of use. This is pretty similar. Many software developers unknowingly develop code with this software bug. It's caused by changes in a system between the checking of a condition and the use of the results of that check.
So consider a web application that allows a user to edit pages and also allows administrators to lock pages to prevent editing. A user requests to edit a page, getting a form by which he can alter its content. But before the user submits the form, an administrator locks the page, which should prevent the editing. So taking into account that type of situation, the software developer and probably developed the software thinking that a user would edit a page, he would hit submit, and then a administrator could lock editing and not allow anyone to edit. It may not account for the possibility of someone opening a file to edit it, and before they complete the edit, an administrator locks it. So it's little nuances, little situations like that that software developers have to be able to account for. And then some typical hardware, we've got CPU. This is another easy term that we can't take lightly. It's always the easy stuff that we take lightly that winds up tripping us up on the exam, stuff like physical security, you know. But CPU is the hardware within a computer that carries out the instructions of a computer program by performing basic arithmetic, logic, and input-output operations of the computer system. There are two major components of the CPU, and we need to make sure we know that. There is a control unit and arithmetic logic unit, or ALU. The control unit in a CPU coordinates activities of other CPU components during program execution. It's like the traffic cop. It's controlling traffic in the CPU. This program can use this part of the CPU. Now this program can use it, and so forth. The arithmetic logic unit performs calculations of a numeric nature and comparative logic functions. So the control unit is the traffic cop. The ALU is the calculator of a CPU. Firmware is usually read-only memory device that contains hard-coded instructions that tell the computer what to do during startup. And the fact that it's hard-coded means that it can't that code can't be altered. But if you buy a brand new computer that doesn't have an operating system on it, you bring it home, take it out of the box, plug it into the power and turn it on, it's going to boot up, and the first the first code that's going to be accessed is the BIOS, or the firmware. And then that usually tells the system to either go to CD-ROM drive, a USB drive, or the hard drive for further instructions on what to do. It can also point it to a hypervisor in dealing with cloud technology to be able to spawn off multiple operating systems on one physical system. Middleware is a type of connectivity software that enables multiple processes running on one or more machines to interact. And these services are collections of distributed software that are present between the application running on the operating system and the network services which reside on a network node. All right, this is another really important slide here. Software, whether it be you consider it an application or a software program, they are static lines, passive static lines of instruction for utilizing physical system resources, the CPU, the RAM, all those physical components of a computer system. But the key here is that they're passive lines of instruction. They don't do anything unless they're initiated. So some examples of software operating systems. Operating system controls the operations of the system's physical components, including input and output to peripherals and the processor. Applications are passive lines of instruction that are used to perform functions that the operating system doesn't perform. Otherwise, we just need an operating system and to have all the functionality that we need. It's not until we spawn a process that something actually happens. So a process represents the actual execution of program instructions. And we have processes that run in different states. So again, passive lines of instruction are software, could be operating system or application. In order to make something happen, you spawn a process. You could also spawn multiple threads. All right, but let's talk about the processes real quick. Again, a process represents the actual execution of program instructions. So a process is in a new state before it has been loaded into memory. You're at an application, you've opened the application, but before you actually initiate something to happen, a process is in a new state. It hasn't been loaded into memory. Once it's loaded into memory, then it can gain access to the CPU. A process is in a block state when it's waiting for user input. And I always use the phrase blockhead. A process is in a block state when it's waiting for a blockhead to provide input. A process is in a ready state when it's waiting to send instructions to the CPU. So it's loaded into memory, it's ready, and it's waiting to send instructions to the CPU. And then a process is in a running state while the CPU is executing those instructions. All right, so running state is easy. A new state is pretty easy. I think ready state may be the most difficult one when it's waiting to send instructions. And then blocked state is easy if you think of a blockhead when it's waiting for the blockhead's instructions, the user's input. All right, and then we said a process could then spawn multiple threads to execute multiple program instructions at a time. Multiprocessing means having multiple processors in a computer system. With multitasking, the operating system switches from one task to another in an effort to speed up processing. Multi-threading, we said passive lines of instruction or software programs or applications. They spawn processes, which can then spawn threads. So with multi-threading, the operating system splits a single thread into multiple threads. It runs one thread for a short period of time, then switches over to another thread for a short period of time before returning to the previous thread. And this way, multiple threads seem to be running simultaneously. Storage and memory. Computer data storage is referred to as storage or memory. Storage is a component of a computer that retains information or data over time. Our primary storage or primary memory is the memory inside the computer, and it's directly accessible to the CPU. RAM would be an example of primary memory inside the computer, directly accessible to the CPU. Cache memory is actually a component of the CPU, so that's inside the computer and directly accessible to the CPU. Secondary memory is not directly accessible by the CPU. The computer uses input-output channels to access it, for example, hard drives or flash memory. And then virtual memory is memory created by using the hard disk to simulate additional RAM. So if you've got 2 RAM chips in your system, 8 bits a piece, 16 bits in total, and you want to add another 8 bits, then you can have a certain 8 bits on your hard drive reserved, and your system, if it recognizes it as virtual memory, will treat it as if it's primary memory inside the CPU instead of the secondary memory source that it comes from. And we said cache memory is the RAM inside the CPU that's used for fast lookups, is the key word there. If you perform a lookup on something, that lookup is going to stay in the cache. The first maybe 5, 6, 7 lookups are going to stay in cache, so that if you look up the same thing again, you'll have faster access to it. Sequential memory is memory that must be read in sequential order, such as a backup tape, the actual tape that we use to back up information. Sequential memory searches from the beginning rather than directly accessing the location of the information. So imagine a tape drive with a bunch of information stored on it. When you want to access a certain piece of information, the search will start from the very beginning of the tape until it gets to the piece of information that it has requested. With random memory, unlike sequential memory, random memory is primary memory that can be accessed directly in any random order. The search will not begin from the beginning of the media. It will go directly to the location of the information requested.
2 more questions. Oh, you won. You did it. God, okay.
That's a good explanation right now.
Oh yeah, we were just going through it earlier. We were
just
talking about
about
that
it,
one
yeah.
earlier. I'm like, that's the only one we hadn't had yet.
Yeah,
All right, here we go. All right, last question. I'm burning this one up. Real quick. I hope you're ready.
there's no way you're gonna win. She has to get it wrong.
Too easy. Too easy.
I was getting locked out.
I see that you were.
Did she get knocked out on the last question?
No, I did not.
No, you got it right.
Ooh.
All right, everybody out. Go home.
Great job.
Wait, you sabotaged one, you said.
There you go.
Everybody out.
Now there's 2 of us.
This is not supposed to happen. Unacceptable behavior. Don't tell anybody.
Aaron didn't sleep last night.
This one was like Vegas.
Well, I did go back and study like a little after dinner
There you
this
go.
morning.
Some of the textbooks. I'm just kidding.
Only about one.
All right, let's get to this last short domain. I want to play a round of Jeopardy just so you guys get the experience.
Oh no. That's a Jeopardy question.
Everybody loves the puzzles anyway. And it presents the information to you from a different perspective.
Yeah, I think I'm hard.
Yeah, I